Let's start the first lesson of Chapter 3. And in the first lesson of Chapter 3, we'll be covering the definition of the derivative. And in calculus, we'll be using the word derivative a lot. All right, so this is a reminder that derivative is just a fancy way of saying finding the slope. All right, so we want to find the slope for any graph at any point. All right, let's take a look at this graph below here. Let's label this f of x. And this is a linear line here, right? So the y-intercept is 4, and I guess the run right here will be 3. So the equation of this line is 4 over 3x plus 4. And since the slope is going downwards, it's negative, right? So the equation of that line is negative 4/3 x plus 4. Okay, so the question that I like to start off is that find the slope when x equals to negative 3. Okay, so where is x equals to negative 3? Well, negative 3 is about right here. This is negative 3. And if I go straight up, the question is, what is the slope of this line? Well, that slope of that line is constant because it's a linear function there. So the slope is going to be negative 4/3. So in Math 10, you might write that as m equals to negative 4 over 3. Okay. If I move over to this graph over here, let me label this once again as f of x equals to a negative 4 over 3x plus 4. Now in Calculus 12, instead of asking what is the slope, we might ask the exact same question by saying find the value of the derivative at x equals to negative 3. Okay, so remember, derivative just means slope, correct? All right, so we know the answer is negative 4/3, but the way we write that is, well, we have a few options. We can write that as f prime of x equals to negative 4 over 3. And more precisely here, we can change this x here, and we can write that as negative 3. Okay, so this notation right here, f prime of negative 3 means the slope when x equals to negative 3 is negative 4/3. All right, so that is one way where you could write the derivative value. Another way you can write that exact same idea using a different notation is going to be dy over dx, and that would equal to negative 4 over 3. Okay. Another way you can kind of write that is sometimes we'll say y prime equals to negative 4 over 3. So these are 3 common ways that do come up in this course where you need to write the slope at a particular value, and the notation we use is f prime, dy over dx, and y prime. All right, so you pronounce this thing prime. Okay, so those are some ways where you can now add some new notation to your skill set now. Okay, let's move on to the later part of the notes now. So one idea that we looked at in the limits lesson, or the limits chapter, is the concept of an average rate of change, and we usually apply that to when we're given a secant line, right? So the idea is if I have a point right here, and if I want to find the slope at that point, we need to approximate that. All right, so we need to approximate that by drawing another point. And then as you can see, we can draw this blue secant line now through that point, and then we can find this slope called the average rate of change. And this is an approximation or an estimate of the slope by saying f of b minus f of a over b minus a. Okay, so if I had to add to this, this right here would be your a, this right here would be your b, this right here would be your f of a, and if I go straight across, this is f of b. All right, so that's the average rate of change to approximate the slope at this red dot, and that's an estimation, right, called the average rate of change. Now, if I move over, the idea is instead of approximating, how can I improve the slope at this particular point? All right, so as you can see, now we use a tangent line. All right, so a tangent line is very precise because we can write this statement here, limit as h goes to 0. That limit as h goes to 0 eliminates the approximation part and gives you the exact slope at that point. And the notation we use is f of x plus h minus f of x all over h. Okay, so there you go. That's the difference between the two concepts right there. One gives you an approximation of the slope at a particular point, and this new idea gives you the exact slope at this particular point using this new expression right here, and this right here is called the definition of the derivative, right? So this right here is what lesson 3 is all about. Chapter 3, lesson number 1 is all about. This is called the definition of the derivative. And we'll be using this entire lesson to kind of practice this particular concept. Okay, if I move on to the second page right here, let's look at some more definitions here. The derivative of a function, if you're given y equals to f of x, is the general equation that will allow you to calculate the, well, we'll call this the derivative value. And when I say derivative value, based on the previous example, that was the negative 4/3, right? That's called a derivative value. And in simple, like just math 10 terms, that's the slope of the line, right? So slope of the line, derivative value. Okay, so the slope of the line is really the grade 10 language, and derivative value is really grade 12 or calc 12 more specifically in terms of terminology. And the process of finding the derivative, so whenever I'm taking the derivative, I just say differentiate. Right, and you can also have this word as well. I'll give you 2 statements here. Differentiation. There you go. All right, so whenever I need to find a derivative, I'll say differentiate. Here's the kinds of the different types of notation that are out there. The derivative of the function f of y equals to f of x. So whenever you're finding the derivative, these are the different kinds of notation you can use. I'll be very honest with you. I'll be using kind of this notation, and that notation. Those are the 3 styles that I usually generally use, but there are other ones, example like that as well. So just be familiar with the different types of notation when you're trying to find the derivative. And in all honesty, once you do more problems, you will get familiar with this style of notation here. Okay. And this another. So a few more definitions before we start doing problems here. Sometimes finding the derivative is also called the instantaneous rate of change. So because we're finding because the limit is h is going to 0, that creates that tangent line. Sorry. So if I want to find the derivative value at that point, we can also sometimes call this the instantaneous rate of change, because this right here is one particular point. So another term that's out there to describe the slope at a particular point is called the instantaneous rate of change. And as you can see right here, we use the value m here, which really just means slope, right? And another type of notation that's out there right now that if you want to find the derivative value is this notation right here. I believe in my very first example, what I wrote was f prime of negative 3 equals to negative 4 over 3. So I generally write this because it's shorter, but you can also use this notation right here, so that if I applied this particular instruction to the above box there, that would be f prime of negative 3 equals to dy over dx, a vertical line, and our x value is going to be negative 3, and that equals to negative 4/3. Okay, so I guess what I'm just trying to say right here is this green region right here that I'm circling is very similar to this idea, but I just kind of like this a little bit better just because it's shorter to write. But you'll definitely see this notation in your graphing calculators as well, so you want to be familiar with what the notation means. Okay, let's go ahead and start doing some problems here, and then hopefully the notation will slowly become more familiar with the different types of notation by using by doing the example problems here. Okay, so I want to find, for this function right here, I want to find f prime of a at x equals to 1 and x equals to 2. Okay, so before we do this problem, let's just draw a little grid here. And I know my parabola is opening up, concave up like that. And my x values are 1 and 2. Okay, so if I go straight up, here's a dot, here's a point there, and there's a point right there. Now the only thing that I can really conclude about the slopes at x equals to 1 and x equals to 2 is that the slopes they appear to be positive, right? The slopes are positive. And I would say that this slope here, yellow, seems to have a greater slope value than the slope which I'm highlighting here in blue. All right, so the question here is I want to find the slope values of that yellow line and that blue line. Just by drawing this, I can conclude that they're both positive, but the yellow line seems to have a higher slope value than the blue line. Okay, so instead of using the word slope sometimes, I'll be saying the term derivative so that we get familiar with that concept. All right, so here we go. Use f prime of a. Okay, well, basically what I'll do here is I'll just write this as f prime of x, because I'm not 100% sure. Let's just pretend we don't know where x values are, even though we know it's x equals to 1 and x equals to 2. But this means find the derivative, and I can start off by writing the limit statement. This is the definition of the derivative here. I'll say x plus h minus f of x all over h, right? So this is the definition of the derivative right here. And what we want to do is, this is kind of like a formula, and we're plugging a function into the formula, right? Okay, so let's go ahead and now input the function into this formula here. When I'm starting, I generally find that the h is a little bit easier to write, so I'll write the h down there. This minus sign matches up with this minus sign there. And what's my function? Well, my function is x squared plus 1, so in a bracket I will write x squared plus 1. Okay, and just as a little review here, now I need to find f of x plus h. Okay, so on the side here, we'll do one more side calculation here. So if f of x equals to x squared plus 1, our goal is to find f of x plus h. And once again, all you're doing here is you're taking the x values and you're replacing that with x plus h. So this will be bracket x plus h squared and then plus 1. Alright, so this right here is f of x plus h. Okay, I'm going to go ahead and expand this because this is really just x squared plus 2xh plus 1 and then plus a 1, which is really x squared plus 2xh plus 2. Okay, so let's go ahead and write that down, x squared plus 2xh and then plus 2. Okay, after that, now we're pretty much done the substitution step. Now we just distribute. Okay, so I'll write another line here, x squared plus 2xh plus 2, and then we have the minus x squared and then minus 1 all over h. And this is the limit as h goes to 0. Okay, alright, so this and this will cancel off. I would say okay, so let's go ahead and now solve the problem here, because the instruction is to find the slope of the tangent line to the functions at x equals to 1 and x equals to 2. Alright, so whenever you need to find the slopes here, I would start off by writing the definition of the derivative one more time. So the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay. And now we're going to plug, this is our, you can think of this as a formula, and we're now plugging functions into a formula here. So on my next step, we need to substitute the functions correctly into this formula here. So I kind of start off by writing h on the denominator here, and then we have this minus sign there. So this minus sign is that minus sign there. And what's my function here? Well, my function is just bracket x squared plus 1. And sometimes when we're getting familiar with the definition derivative, students need to become familiar with this part right here, which is f of x plus h. And on the side here, I'll just write f of x is the original function, which is x squared plus 1. And what we need to do is we need to find f of x plus h. Alright, so basically what this really means is anytime you see an x, the x's get replaced with x plus h. Alright, so this will be x plus h squared and then plus 1. And then if I expand that, this will be x squared plus 2xh plus h squared plus 1. Alright, so this part right here is really f of x plus h. So I'm going to just plot that over here now. So this will be x squared plus 2xh plus h squared plus 1. Alright, and then from here on is just algebra here. If I distribute this and this, you need to see that this x squared and that x squared will cancel out. And this plus 1, when you distribute that minus sign, becomes negative. So this positive 1 and that negative 1 will cancel off, right? So this and this cancel off, but this and this also cancel off, right? And now you're left with 2xh plus h squared all over h. And that's the limit as h goes to 0. And if you keep on going here, let's go ahead and keep on simplifying here. So h goes to 0, and then you can factor out the h, which is 2x plus h all over h. And then finally you get something nice here. The problem variable goes away. And I'm going to write out one more limit statement here. These are all algebra steps here, so 2x plus h. And then finally we can use the direct substitution step there, and then we get 2x. So there is my derivative expression, is 2x. Okay, now once again, let's go back to the original problem here. My derivative expression is 2x, right? And I want to find the slope at x equals to 1 and 2, all right? So at the start of this problem, we concluded that the slopes are positive, but definitely the x value at 2 has a greater slope value, right? So now we can write f prime of 1 equals 2, and then 2 times x. Now what's the value of x? Well, that value of x is just 1, right? So the slope when x equals to 1 is going to be 2. Okay, then after that we need to find f prime of 2, right? So what's the slope when x equals to 2? And that's really 2 times, and then we take this 2, we plug that into there, so 2 times 2 is going to be 4. Alright, so there you are. Our slope values are 2 and 4 at x equals to 1 and 2 respectively. Great. So I would say 80% of this problem is really being very diligent with your algebra steps. Okay, let's move on to part B, and this one says find the equation of the tangent line in point slope form. Alright, so point slope form, that's going to be y minus y1 equals to m bracket x minus x1. And we need to sketch this, right? Okay, well, let's just sketch the problem that we just did. It's very good to kind of sketch the problem so that we kind of know what's going on here. So this is the value at x equals to 2. And our equation of our line was y equals to x squared plus, I believe it was plus 1. Yeah, plus 1. Okay, so if I plug in 2 into there, that gives you 2 squared, which is 4 plus 1, so that's going to be 5. Okay, so that was her point right there, right? Okay. Erase all that. I don't need that anymore. Okay, so let's go back to the question now. It says find the equation of the tangent line. So the tangent line is really, this line right here, right? That's the equation of the tangent line, right? So I want to find the equation of that green line in point slope form when x equals to 2. Okay, so let me kind of rewrite the equation in point slope form over here. Alright, let's plug in what we know. That goes there. This 5 goes there. Oops. So it's kind of messy there. So y minus 5 equals to m bracket x minus 2. Okay, so that was a bit sloppy there. I apologize. Alright, and then using calculus, what was the derivative value when x equals to 2? Well, from the previous question, we found that the derivative value when x equals to 2 has a slope value of 4, right? So m becomes 4. So our final answer is y minus 5 equals to 4 times x minus 2. Alright, so this right here is definitely okay for my calc class. If you want to go ahead and write this in terms of y plus mx plus b, you can. That's 4x minus 8. Bring the 5 over, and that's going to be y equals to 4x minus 3. Alright, so that's the equation of the tangent line. So if I had to kind of draw the tangent line accurately, I guess the tangent line has a y-intercept of... Alright, so maybe my tangent line looks like that. Okay, so that's the equation of that tangent line is 4x minus 3. And we'll be doing a lot of that in Chapter 3, Lesson number 1. Okay, let's move on to the next one, right? So basically I have 2 more examples here, and we just find the derivative of each function here. And when we're finding the derivative, alright, that's pretty much using this notation f prime of x. That means find the derivative, and we can do that by using the definition of the derivative here. Right? So that's what it means to find the derivative, is to use the definition derivative and find what what the derivative expression will be. Okay, so I hate to do this, but I will write the definition of the derivative one more time. So the limit is h goes to 0 of, actually let's just go ahead and start using it right now. I know h will be here. I know the minus sign is right there. Okay, so that minus sign is that minus sign over there, and that's the h right there, right? So I'm just going to go ahead and start applying the definition of derivative here. Okay, now the function here, f of x, right? So what's f of x? Well, f of x is this thing right here, so that's going to be 2x all over x minus 1. And now we need to find this f of x plus h, right? So what is f of x is equal to 2x all over x minus 1. And if I want to find f of x plus h, all we're doing is that we're taking the x's and we're replacing that with x plus h. So this would be equal to 2 bracket x plus h all over x plus h minus 1. Okay, so if I have to go back to the problem here, I would just write this as 2 bracket x plus h all over x plus h minus 1. Okay, I'm going to erase all this. Alright, so now in order to kind of finish this problem now, you're just using a lot of algebra here, right? So I'm going to use the crisscross smiley face technique first. So in order to do that, I will take this part right here, x plus 1, and I'm going to multiply that with this numerator right there. So I get 2 bracket x plus h bracket x minus 1 minus, and then I'll take this part right here and I'll multiply with that. So that's going to be 2x bracket x plus h plus, sorry, not plus 1, but minus 1. And then we divide that by, and then when the smiley face technique is you multiply those two terms together, so x plus h minus 1 times x minus 1, and then this all divided by h. Now as you're writing your notes, I want you to look at this and make sure you're familiar with the crisscross smiley face technique. And you should also be comfortable that this h can move right there. Alright, so that's how I would rather write it. And now you're kind of ready to take the next step in distributing this, right? And simplifying and foiling, right? So let's go ahead and now just look at the numerator, right? The numerator there, we have to do quite a bit of canceling and simplifying the numerator there. So let's go ahead and do that. So if I go ahead and do that, that's going to be 2x plus 2h onto x minus 1, and then if I distribute this on with the minus sign, that'll be negative 2x squared minus 2xh plus 2x all over h times x plus h minus 1 times x minus 1. And since these are all algebra steps, write the limit as h goes to 0. Okay. We have to do one more FOIL step here. So if I FOIL that, that's going to be what, 2x squared. And then FOIL that, that's going to be minus 2x. And then plus 2xh minus 2h. And then we copy all of this down, minus 2x squared minus 2xh plus 2x all over h bracket x plus h minus 1. So yeah, quite a bit of algebra steps when you're doing the definition of the derivative. Alright, fantastic. Now let's go ahead and start canceling things off here. So this thing and that thing will cancel off. So that and that will cancel off. I would say this and this will cancel off. This and this will cancel off, which is great. So when I take a look at all this, this all simplifies to negative 2h on the top, all divided by h bracket x plus h minus 1 times x minus 1. The limit as h goes to 0. And I would say that and that will cancel off, giving you the limit as h goes to 0 of negative 2 all over all this now. And then from there, you can just substitute h goes to 0 there. If I do that, now we get this. So x plus 0 minus 1 is just x minus 1. And then we also have this x minus 1. And that right there is correct. I'll take that, and if you want to simplify this further, I mean, I guess you can write x minus 1 all squared. All right, so that right there is the derivative. As you can see, this takes quite a bit of algebra work, and I think the algebra steps is probably the most important when you're doing these kind of particular problems. All right, let's take a look at example B here. I want to find the derivative of y equals to square root of x divided by 2. All right, so if I want to find the derivative, let's start by writing out the definition of the derivative. So the limit is h goes to 0 of f of x plus h minus f of x all over h here. All right, so the definition of the derivative allows us to find the derivative for any function here. Okay, so let's go ahead and now insert the function into our definition of the derivative here. If I do that, I have h on the bottom minus, and now I have root x over 2. That's generally great. And then just remember, once you do enough of these, you'll get familiar with the process. And whenever you see an x, you just replace that with x plus h. So that's going to be the square root of x plus h divided by 2. Okay, so now this is looking like a question that you may have seen in the limits chapter here. It's really just more algebra, and maybe we'll have to use a conjugate step here. Okay, so let me kind of erase this and just write it out a little bit bigger here. So square root of x plus h divided by 2. Okay, I will go ahead and use the crisscross smiley face method first. So let me just use a different color here. So this 2 will now multiply with the numerator there. So that'll be 2 times the square root of x plus h minus, and then this 2 will multiply with that. So that's going to be 2 times root x. And then finally, this red 2 and that 2 will times together, and that gives you 2 times 2, which is going to be 4, all divided by h. And I'll write the limit statement over here. And just like the previous question, instead of writing this ugly fraction, you can move this h right there to get 4h. And now you have that. Okay. Now this is looking a lot nicer because if you remember from last chapter here, we're just finding the limits of these radical functions. And whenever you have these radical functions and you have a plus or minus sign, as we do in this case, you can multiply by the conjugate, right? So now this is just a limits problem now. So 2 times the square root of x plus h plus 2x. So we're multiplying the top and bottom by the conjugate. All right, and then in order to do that, let me just put a bracket here. And if you remember some of the strategies from last chapter, when you're looking at these conjugate problems, the part that's not the conjugate is really the denominator, right? So this blue part, that's not the conjugate part. So what we can do is do not distribute, just clump them together with proper brackets. All right, so just don't distribute, just put them together like that, and now you can multiply the conjugate parts here. So if I take a look at this part right here, if you multiply that with this first term, well, 2 times 2 is going to be 4, and then root x plus h times root x plus h is simply going to be x plus h without the radical sign. And then if we take this part right here, this negative 2 root x, and multiply that with positive 2 root x, we get minus 4x. And that's how the numerator simplifies too. And then let's take one more step and distribute that. So you get 4x plus 4h minus 4x. And you'll notice that this and this will cancel off, right? Just giving you just the 4h at the top. So what we'll do here is we'll just erase that, and then we get 4h bracket 2 times the square root of x plus h plus 2 root x, and we get the limit as h goes to 0. And then finally, I see that this 4h and that 4h will cancel. That's great. So then we have just now the limit as h goes to 0. There's a 1 on the top, and on the bottom we have 2 times the square root of x plus h plus 2 root x. And now we can use our limit constants, a direct substitution, that h goes to 0. So now we're substituting the value of 0 there. So this would be 2 root x plus 2 root x. And if we go ahead and just simplify that, that'll be 4 root x. Alright, so that concludes this lesson video on chapter 3, lesson number 1, which is the definition of the derivative.